the force that the moon pulls that is much weaker, but it's still following the same acceleration as the center. So it lags behind because the moon is not pulling that part of the Earth within the force to match the acceleration of the rest of Earth that is closer. So that gets lagged behind for the moon pulling with a weaker force. That's why you have a bulge. In that case, there is no outside, there's no upward force. It's just less of a downward force.
But the thing is, if you treat the Earth as the basically non-moving frame of reference, the bulge on the opposite side of the moon wouldn't make any sense. So you have to treat it as a system where both bodies are rotating each other.
Yes, but I'm doing that on a frame that is inertial. So in an inertial frame, the moon is pulling Earth with various different forces. So the point that is further away from the moon is just being pulled with a weaker force, so it lags behind the rest of Earth, and that's why you have the bulge. So that explains the centrifugal force is just the lack.
Yeah, I heard this explanation as well. In my opinion, I find this very counterintuitive. So this it's like you're kind of stretched, like you pulled and you're stretched apart because the closer part is pulled stronger than the further away part, and therefore you are kind of
that's exactly
all these pseudo fictitious forces are not measurable, dude. You're just in fantasy land.
Well, you can definitely
as I said,
measure.
I don't really like this explanation of pulling apart, because I think what is very well measurable is the that you get lighter on the opposite and on the facing part, and this is very easily explained with orbital mechanics.
Yes, but that's an explanation where Newtonian mechanics doesn't apply very well because it's a non-inertial frame.
The only place orbital mechanics can work in your mind is somewhere where you can't go. You can't measure it or show it in a lab.
Oh, me.
Having two different conversations.
Of course, you can demonstrate orbits in a lab. You can have magnetic forces.
Can't.
Yes, you have static forces. You have magnetic forces, so electrostatic forces. You can orbit, for example,
gravity forces.
You can orbit, for example, styrofoam balls around a statically charged rod or something like this.
Did you do that with gravity?
No, we can do that with other forces. So, are you challenging the mechanics of orbits, or are you challenging the existence of gravity? Which one?
He doesn't believe in gravity.
Yeah, but it seemed like he was challenging orbits in general. Like things shouldn't be able to orbit. Now he seems to be challenging the existence of gravity.
Orbits in relation to gravity. Okay.
And before he was challenging the measurability of pseudo forces. It seems that every next sentence is a new challenge.
You think Coriolis is an actual force?
Yeah, now he's challenging Coriolis. So again, every next sentence brings a new challenge. I'm not sure we can have a conversation like that.
It's just galloping.
I think you guys should let them go. They were getting close to solving the three-body problem, right? Like
now that's a new challenge.
It's all false. You guys are getting close. So just let them go. They'll figure it out.
It keeps multiplying the amount of stuff we have to respond here. Every new sentence just doubles the effort.
Wait. You guys weren't talking about orbital mechanics, how the moon and the sun are affecting Earth, and you don't want to say this is a three-body problem?
We weren't talking about the three-body problem. That's not. Yeah, we're talking about tides.
Can you explain what the three-body problem is for you in your understanding? I don't know who engaged there.
We're talking about orbital mechanics, and he starts bringing up a three-body diagram. I mean, come on, really?
Yeah, let me hear what he thinks.
Wait a second. Who came in there with the three-body problem? Who was that?
It was Timor's. Let me hear what he thinks it is.
Yeah, I would really like to hear it.
Okay, why don't you guys tell me what it is? You're all experts. Let's hear it. I just commenting that you guys are about to solve it.
You brought up the three-body problem. Can you briefly tell us what, in your opinion, the three-body problem is?
Well, isn't it where we're trying to explain gravity and three bodies and the mathematics behind how that interaction occurs and what forces are applied on said bodies?
It's
No.
not about explaining gravity. No.
Okay, what is
No,
it?
and it's also not like that the mathematics doesn't work with these three bodies or so. Or we couldn't compute it. Do you
All
want
right,
to try
guys.
again or
Yeah,
Educate me.
I'll do it. Can I do
okay.
it, or do you want to do
Yeah,
it?
go ahead. Go ahead.
Okay. The three-body problem is the fact that when you have more than two bodies in a system, there is no closed form solution for the positions and velocities of those bodies across endless time, except for specific scenarios. There are only numerical solutions. So that's what the three-body problem is.
So that means you cannot write it with some characters and some dots and strikes and so on, and write it on a paper and say this is the solution. With two
You can
bodies,
only
there is this kind of formula that you can write, but with three bodies, there is not a single discrete formula that you can write down that solves that thing. This is the three body problem or the n body problem.
There's an element of randomness and something chaotic in that system that you cannot predict.
Yeah, but there are
You cannot
numerical
actually
methods, by the way.
Yes. Yes, it
It's
is
not that
solvable.
we have no
It is
solution.
solvable. It is well calculatable. We know it. We know it so good that we can predict like eclipses like 100 years in the future because we exactly know where all the bodies in the solar system will be in 100 years. Very precisely. Because we can all calculate it. It's a solved thing.
But it has the word problem in it, so it's gotta be a problem.
It's the same like pseudo forces has the word pseudo, therefore they are not real. This is also bullshit. Pseudo forces are just forces that are derived from another force.
No, they're dependent on non-inertial frames.
No, pseudo forces are just like secondary forces. It's not the root force that is happening here. It's something that you put some other things together and you phrase it again as a new force. You summarize
it's more of a reference frame.
No,
it's a reference frame
not,
dependency. It's a reference frame dependency, and basically it's a resultant. It's a mathematical equivalence of a force to create the motion that you see when looking at it from another reference frame. So when you see things deviate, like for Coriolis, there's a Coriolis force, but it's really not a force. It's just the apparent deviation. But what would cause that deviation in a non-rotating or in a non-inertial reference frame? Well, that equals a force to do that curved path that a projectile would take.
And you don't even need a deviation.
It's just a reference frame. It's a reference frame dependency of for that force. It has no source and it's reference frame dependent.
Blah blah. Jeremy, these guys telling all these fairy tales, these are the same guys that think when you push on the wall's pushing back.
Well, with the Coriolis force,
if you spin a table and you rolled an orange across
you just went. Can I go?
You know what? Let me I have to, because he thinks we're just making shit up.
You just went and then he addressed me. I mean,
can I have 1 second for just a quick example? A table. Let's say we have a turntable and we spin it and we roll something across it. This is the thing you've seen millions of times. That if you're looking at it from the rotating perspective, it looks like it's going straight. But if you're looking at it from the static perspective, it looks like it's taking a curved path. Well, the curve path just needs some forces that applied to that with respect to that particular frame to make it take a curved path. But in actuality, it's really going straight. That's all Coriolis is. It's just a perspective. It's like what frame you're looking at it from. And if you're looking at it from a frame that makes it a curve, which it shouldn't, there's a force associated which makes it curve where it shouldn't. And that's the Coriolis force. Does that make sense? No? Okay. I tried.
Oh, I just want to add, you don't need any deviation to have non-inertial forces.
I said specifically for Coriolis force.
Right, man.
We're talking about non-inertial force in general. Right?
No, I'm just trying to explain what he says. These pseudo forces are made up, and we're all full of shit. And we're just making things up. No, there's actually a reason why we call them.
I know. You're saying that. I'm just adding to what you said, like saying it's not important that we do have a deviation. For example, if you have a train moving on a track, and then you rotate the whole system, you're going to have pseudo force, even if the train isn't deviating, because it's forced to be on the track. You still have the force there in that rotating frame, because there would be a tendency for the train to fall outside of the track, even if it doesn't. The force will be there. So there is no need for an apparent deviation for the pseudo force to exist. It will exist either way. That makes sense?
Yes.
Well, it's not only an apparent. It's not only an apparent deviation. It's a real deviation that would happen.
No,
if we were
he's just giving you the opposite of what I told you. So I said we see you throw a projectile that takes a curved path. There's a curved path. He's saying if there's not a curved path, there's a force created. That's why they call it a Coriolis force. So a railroad tracks going north south, there'd be a Coriolis force that would put pressure on one side of those wheels on the tracks, even though it didn't deviate. So it's not deviating, but there's still a force. In my example, there is a deviation, and there's a force associated with which makes it deviate like that. It's not really a force; it's called pseudo force. Does that make sense? I mean, we're trying to give you both ways so you understand it. All you're doing is calling us liars and making shit up, and we're not. It's actually pretty common standard concepts here.
Who are you talking to?
You.
I just got here. I think
you
Jeremy
also
was
said
trying
something.
to get in.
Talking to
And
everybody.
of course, the water's pushing back.
There's a Coriolis force and a Coriolis effect. The effect is the apparent deviation from an outside viewpoint. And then the Coriolis force is due to the tangential gradient of the supposed rotation of the Earth. It should be faster or slower towards the equator.
Oh, anything. Like you can have Coriolis force. You don't need to have Earth as a whole. You can just spin a table, and then you're still gonna have.
It's just the equivalence factor of what force it would take to make that object accelerate as it does. And I don't mean just acceleration like it's a change of velocity. It doesn't have to be a change of magnitude. It can be a change of direction, which the Coriolis force addresses. And then if it's not, as Bacon said, just going straight like a train track on trains going north-south, there'd be a force on that track which would wear the one wheel more than the other, one side more than the other.
I don't know who's having problems understanding that.
Me.
Vibes.
Oh, he answered himself. Yeah, it's bullshit. I mean, it has the word pseudo.
If a bird flies over my head, it's the same thing. If a bird flies over my head, you would say there's some type of a force involved between me and the bird.
What force?
That's what Coriolis is to you. You think there's a magical force there.
We said it wasn't. We already told you it wasn't. If it actually, look, one more time.
How is a bird? Okay,
no, that bird's dead. If that bird is dead and I throw it north, it'll deviate to the east. That's the Well, let me just finish. It's 5 seconds. The
bird is dead.
I'm just getting tired of explaining this. The bird's dead. We throw the bird in the air north. It deviates to the east. That's a Coriolis effect. If we threw it down a tunnel, like a long tunnel, north and south, and it had to stay in the tunnel, the Coriolis force would be the size of the container, which wouldn't let it go east. I mean, I don't know how much more simple we can make it. And that is due, as Perspective said, due to the rotating conditions, this non-inertial reference frame. Things moving in a non-inertial reference frame will experience things like Coriolis.
Not a force.
Oh my God.
What about not being a force is an issue here?
Yeah, put me on the list, man, whenever I can get it.
Jeremy, go. You show them, motherfuckers.
The Coriolis kid in effect. Now listen, when you do that thing, when you throw a ball over the merry-go-round or whatever you're doing, right? That deviation is not real. I mean, it looks real to the guy on the spinning or whatever, but the deviation itself is not real. That ball's actually going in a straight line. You know how we know we can put a meter stick up against it, and we know meter sticks are straight, right? You could put a meter stick and roll the ball directly along the meter stick. So we know it definitely went in a straight line because we know meter sticks are in a straight line. And then if you get on a merry-go-round underneath it and start looking, it looks like it deviated. We know it didn't actually do that. Because we actually know that meter sticks are straight. Do we know meter sticks are straight? Let me go down a line of questioning with you real quick and we'll see.
Yeah, the person in the merry-go-round can also use a meter stick, and then it won't follow the meter stick, right? It will only follow the meter stick for the person that is not on the merry-go-round.
Do we know meter sticks? Can I go through a line of questioning with you, or are you going to fight me the whole way?
Yeah, they're straight. If that's your next question.
Meter sticks are straight, right? We know that if we put a meter stick in the ground and it is planted in the ground and it's it's on a pole going outwards, we know that's definitely straight. And then if we roll a ball down the meter stick and it always was touching the meter stick, then did the ball go in a straight line?
Yeah.
Yes. Okay. So now if a person gets in a merry-go-round underneath that and looks at it, it's going to look like it didn't go in a straight line now.
Yes, and they can
Right.
use a meter stick to check that, and it won't follow their meter stick, right?
No,
But
we already
in
have the
relation
meter
to
stick.
the,
We already have the meter stick. It's planted in the ground. We know it's straight. Right?
Yes, the person that is holding another meter stick is also straight. I mean, not the person,
Yeah.
but it could be a gay person. But the stick he's holding is also straight.
but in relation to the rotating body, it did deviate, right?
Yeah, that's like the whole point. Like if your definition of actual is what's planted on the ground, meaning what's inertial, then yes, the deviation is not real because it only
Well, we
happens in
know the
inertial frame.
deviation's not. We know the deviation's not real because we can get 10 merry-go-rounds all spinning at different speeds, and they all see a different thing. They all have a different thing going on, but we know it's
Okay.
actually just going straight. We know how to throw a ball straight on Earth, right?
Yeah, you're saying the default is the one that is planted on the ground. That's the actual one. Sure, if that's
Well,
what
the
you mean by
default is the
actual,
one
then
that can't. That's
if
not
you
what
if
I'm
that's what
saying. Go ahead. Go ahead.
say, I would say if that's what you're saying, then I would agree. So if that's not what you're saying, then what are you saying?
But hey, Jeremy, if you had a straight line established where the ball was going to go, and you had a person at the end of that straight line on the rotating platform, right? And then you threw the ball with the spinning rotation. For the person that's at the end of that line, it's going to deviate. It's not going to hit that person because the rotating platform has rotated. Even though the ball was in a straight line, according to the person, it deviated from its original straight path because it's on the rotating reference frame. So according to the person on the platform, it did deviate. According to the person inside the ball, it didn't deviate.
No, it only looks like it deviates. It doesn't actually do that. Do you know how we know
Well,
it doesn't
in
actually do
relation
that?
to
Because we
the
can get 10 guys on 10 different merry-go-rounds and they're all going to see a different thing. So we know they can't actually all be doing that different thing at the same time. Like
in
this,
relation
this
to the
only works.
rotating platform,
Yeah, but you could pick
it
any. You could
deviated.
pick any of the 10 guys or someone that is not on the merry-go-round to be the right one. Like you could pick any of them. You're picking the person
There's
that is not
only
in any
one
of the
truth.
merry-go-rounds. Hang on. But I could pick one of the guys that is in the merry-go-round and say, well, that guy's description is the actual one. The other ones are not actual.
You would say there's more than one truth in Bacon.
No, there are different descriptions because those are different frames. What Jeremy's saying is
Yeah,
that
but at
okay, the
the end of
guy.
the day,
Hang on, hang on.
there's a lab frame, right? Which is the frame? Which is the ultimate frame? The truth? Which one?
Depends on where you're at.
Hang on. I think inertial frames would be better than non-inertial frames. So I agree with Jeremy here that the guys who are not in the merry-go-round have the better frame because they're inertial. But that's all I mean. That's all I'm saying. If by actual you mean inertial, then sure, we would all agree with you.
No, I
But
mean
That's what we're trying to get to the
actual. I
bottom
mean
here
actual.
on
Yeah,
Like
this
you
Bacon.
can
channel.
get on a.
Yeah, Bacon.
Oh God,
Okay.
yo, I'm getting in, man. I'm getting in. I mean actual. Like we know how planes actually can fly. Like we know that if there's a jumbo passenger jet flying through the sky, we know the physics of that, and we know that if you get on a merry-go-round and start spinning around super fast, looking at the plane, we know the plane's actually going in a straight line and it's not really doing loop-de-loops. It's not even
Because you're using your
physically.
brain.
It's not even no, not because I'm using my brain, because I know it's not physically possible for a jumbo jet to be doing anything even remotely
Right.
close to
So
that.
let me
yeah, it's not possible to do that in an inertial frame.
Bacon. Bacon, let me say something because before you go through
No, it's
the
not
2 hours.
possible
Hold
to
on.
fly
Let me
like
say
that.
I have to go real quick. I have to leave, so
It's
let me
not
just say
about
real
the
quick.
frames. You just can't fly like that in a jumbo jet. It's not physically possible.
Let me
You
say,
can't.
Bacon. Let me say something real quick because I think it's
Okay.
important. Inertia. So Jeremy and I agreed. He has a definition in his mind that for the word actual, and we both would attach that to inertial. So when he says actual, he means inertial. That's all there is to it. And so yes,
Yeah,
you're
that's
right, Jeremy. Those planes are always going straight. We know how they fly. Even if we're spinning, we know how they fly. It's impossible for them to make loop-de-loops. We get that. All we're talking about is what it looks like. The path it takes with respect to the observer is what the observer sees, not thinks he sees, what he actually sees. If he sees loop-de-loops, he's seeing loop-de-loops. Even though he knows the plane can't go loop-de-loops, it looks like loop-de-loops. From a point coordinate system, it's doing loop-de-loops.
Yeah, in the frame of the person in the merry-go-round, it is doing the loops. It's in their frame. It can't do that in an inertial frame. We all know. Hang on. We all know it cannot do that in an inertial frame. We all know that.
In
But it is doing that.
reality, it can't. In reality, we know. In reality, a plane can't do that because it's not the material science.
He's baiting
It's
you.
not physically possible.
Reality means inertial.
It's not
Yeah,
physically
again.
possible. It's not physically possible for the plane to fly like that. The materials would fly apart. It would destroy itself. Like it's literally around and start spinning around super fast. Like we know that if there's a jumbo passenger jet flying through the sky, we know the physics of that. And we know that if you get on a merry-go-round and start spinning around super fast, looking at the plane, we know the plane's actually going in a straight line and it's not really doing loop-de-loops. It's not even
Because you're using your brain.
It's not even no, not because I'm using my brain, because I know it's not physically possible for a jumbo jet to be doing anything even remotely
Right.
close
So
to that.
let me.
It's not possible to do that in an inertial frame.
Bacon. Let me say something because before you go through
No, it's
the
not
2 hours.
possible.
Hold
to
on.
fly
Let me
like
say
that.
I have to go real quick. I have to leave,
It's
so let me
not
just say
about
real
the
quick.
frames. You just can't fly like that in a jumbo jet. It's not physically possible.
Let me
You
say,
can't.
Bacon. Let me say something real quick because I think it's
Okay.
important. Inertia. So Jeremy and I agreed. He has a definition in his mind that for the word actual, and we both would attach that to inertial. So when he says actual, he means inertial. That's all there is to it. And so yes,
Yeah,
you're right, Jeremy. Those planes are always going straight. We know how they fly. Even if we're spinning, we know how they fly. It's impossible for them to make loop-de-loops. We get that. All we're talking about is what it looks like. The path it takes with respect to the observer is what the observer sees, not thinks he sees, what he actually sees. If he sees loop-de-loops, he's seeing loop-de-loops. Even though he knows the plane can't go loop-de-loops, it looks like loop-de-loops. From a point coordinate system, it's doing loop-de-loops.
Yeah, in the frame of the person in the merry-go-round, it is doing the loops. It's in their frame. It can't do that in an inertial frame. We all know. Hang on. We all know it cannot do that in an inertial frame. We all know that.
In
But
reality,
it is doing that.
reality, it can't. In reality, we know. In reality, a plane can't do that because it's not the material science.
He's baiting
It's
you.
not physically possible.
Reality means inertial.
It's not
Yeah,
physically
again.
possible. It's not physically possible for the plane to fly like that. The materials would fly apart. It would destroy itself. Like it's literally physically impossible for a plane to fly.
Everything
Like
you're
as if
saying.
you were on a non-inertial frame viewing it spinning really fast. Like it's physically impossible in reality for the plane to actually do that.
Everything you're saying is correct for inertial frame. So saying that you just mean actual and then saying everything that would apply to inertial frame isn't actually changing the argument here.
You guys are saying it is doing that. I'm telling you, no, it's not actually doing that. It just looks like it's doing that because you're spinning.
Yeah, it is doing that in the frame of someone is rotating.
No, yeah, but it only looks like it's doing that. It's not actually doing that.
It's actually doing that in a spinning frame.
No, it's not actually doing that. It's impossible for it to. Okay, I'm done. I mean, it's just pointless. If you think a plane can actually fly like that,
Bacon, you didn't get my message. Bacon, you didn't get the
literally
memo.
impossible.
Every time he says actual, he says inertial. Just
It's
use that in your
literally
head.
impossible
I know.
for the physics
You'll never have
of
an
the
argument with
plane.
him. Otherwise, you're going
It's
to fight it.
literally impossible for the physics of the plane to rotate like that.
We
The
all know that.
materials will not. The
I'm
materials
helping
will
you,
not
Jeremy.
allow it. It is literally physically impossible.
I'm
The plane
helping
would
you. We all know that.
absolutely destroy itself.
We're helping you. So in Bacon, anyone else in the audience, if you hear Jeremy say actual, what he means is inertial. Simple.
I know,
Don't
but
take any other way.
that's
I know you
destroying
know
the
that,
No, he
Jay.
means in
vocabulary.
You're
And
falling
he
for the
reality.
bait. You're
refuses
falling for
and
the
he
bait of the
refuses
argument.
to use other words.
I know. I'm
he's
saying he's destroying the vocabulary of physics. I'm
I
not
know,
taking
but
it.
you're not going to win that argument. We've already done this for 3 or 4 hours.
I'm not
maybe
trying to
more than
win the
that.
argument.
No,
I'm
I'm
just
just
showing
saying
Is
that.
there a part of physics that doesn't deal with reality?
Oh my God! Here
No.
you go. Reality meaning
That's the
inertial
whole
frame,
point.
their lab frame. We're not talking about lab frames. We're not talking about reality. We're not talking about. All we're talking about is perspective.
No.
Frames
We're
of
talking
a-
about reality
We're
here on
talking
this
about
channel,
reference.
dude. Reality.
All we're talking about is reference frames, which is where you look at this motion from. What frame this point coordinate system for which motion is viewed. Think about it. A point coordinate system for which motion is viewed. That's all we're saying. So if you're looking at it from a fucking ground or on the merry-go-round and you're looking at a plane fly overhead, your point coordinate system is rotating. The object has point coordinate systems. It'll occupy 3D space. And if you look at it mathematically, if you're gonna make a video of yourself like a cartoon, you'd have to input this data into a simulator and make it rotate. It's actually rotating from your reference frame. And that's what Jeremy doesn't like to talk about. We know it can't do it, and it isn't doing it in the inertial frame. It's
Okay,
only
let me
doing
try.
it in the rotating frame. What is wrong with you people?
Okay, let me try to.
No, I'm
Maybe
telling you.
I have
Hold on,
an
Bacon.
analogy.
Let me respond to Zanuck. I know you're going to come up with
Okay.
a whole nother scenario. Before we
That's
do that,
actually
let me
pretty
just,
similar. But go ahead.
you know, let me just explain the materials on a jumbo jet. The physics of a jumbo jet will not allow it to spin that fast. It will destroy itself if it was actually spinning that fast. It's physically impossible. It only looks like it's spinning that fast. It's not actually doing that. It actually looks like it is, but it's actually not.
Okay, let me give you my analogy now. Let's say we are going to fly the drone over the merry-go-round. You use this scenario a lot with the drone over the merry-go-round. And now there are two people, right? One person is standing on the ground, the other is in the merry-go-round, and each one of them has a glass plate. So they have a sheet of glass, and they're going to look through the glass and trace the path of the drone on their glass. So the person who's watching the drone is going to draw a straight line because it's just following the drone on their glass, and the person in the merry-go-round is going to trace a curve in their glass because that's what they see the drone doing, right? You're with me? I guess you're not listening. Never mind.
Yeah, so if you're trying to take a measurement of something moving from a moving reference frame, you're not going to be getting the correct answer.
Oh, it won't be correct in respect to inertial frame, but it will be consistent with its own frame.
Yeah, if we had a merry-go-round, right? I told you to start at the center, and I gave you just enough gasoline to get to the edge.
Oh, you didn't listen to my analogy.
I didn't think you were talking to me that whole time. I'm not trying to like do mad analogies and
I
shit.
was.
You got weird. You said something about glass. Like I was starting to listen, but you lost me like halfway through, so I just stopped.
Okay, let me go again. It's simple. Okay, so there again, we have a drone flying over a merry-go-round, and two people are going to draw the path they see the drone taking. So each one is holding
Is
a.
the drone starting in the center and going towards the edge?
Sure.
Can we give how what's the radius?
I don't think that's relevant. Just pick any radius.
It's going to
Doesn't
be
matter.
relevant because I'm going to expand on this scenario to show you exactly what's going on. What's the radius?
Just pick whatever number you want. Let me just say my analogy, and then you can change it or whatever you want. Okay, so
I'm going to
the
use this
person.
exact analogy, but go ahead.
Yeah, we can fill up the details later. Let me just get to my point. You have a person in the merry-go-round with a sheet of glass looking to the drone, and then it draws the path of the drone in its sheet of glass. And the person who's standing on the ground does the same. The person that is on the ground is going to draw a straight line, and the person that is on the merry-go-round is going to draw like a spiral or a curved path. Right? You follow so far? You're with
Yes,
me?
Baker.
I need to know if
Onto
Jeremy
you.
is with me, because that's for Jeremy. And if he's not listening again, then I'm just gonna stop here.
Yeah, I'm not gonna
So
lie.
the
I
one
started
on the
talking to my
ground,
wife.
the guy on the ground sees the actual path, right? The actual path.
Yeah, but the path.
Oh man, you got a drone going over a merry-go-round. One guy sees it curve, one guy sees it doesn't curve. Okay, now
yeah,
what?
and they draw. The key
Yep.
thing is they're drawing the path they see on a sheet of glass, right?
Yep.
Okay. All right. So when we say in their frame, we're talking about like in their sheet of glass. So in the sheet of glass of the person standing still, it's actually a straight line that they drew. In the sheet of glass of the person who is on the merry-go-round, it's actually a curve. Of course, the path can't be a curve and a straight line at the same time. But those are two different lines. One is the line drawn by a person in the merry-go-round, which is actually curved.
So you admit one's obviously just looks like, right? One's real and one looks like.
No, the curved line is actually a curved line, right? The person
I know, but
actually
that
drew
you
a
said
curved line.
they can't be actually doing both at the same time. You said that. So which one's the real one? I can easily show you which one's the real one, but I feel like you'll fight me the whole way. So
No, I'm saying a line can't be straight and curved at the same time because those are
I
not the
know.
same line. Yeah, so that's what I'm saying. The path the drone takes is not the same on both frames. You have one path for the inertial frame and another path for the other frame. Those are two actual frames, and they describe different paths because they're different frames, but they're both actual frames. Just one is inertial, the other is not.
Yeah,
One was
they
standing
both.
still, the other was rotating.
Okay, great. What's the radius of the merry-go-round? Because I can show you which one's the real line and which one's the looks like line.
Okay, 2 meters.
Okay, 2 meters. I give you a drone, and it has only enough electricity to only fly 2 meters exactly. Then it's going to drop. Right?
Yeah. Mm-hmm.
Okay. Which path are you going to take? You need to make it from the center to the edge. Which path are you going to take?
The inertial one.
You're going to take the one where you fly 2 meters and you're at the edge, right? Because the other one's going to be longer than 2 meters and you're not going to make it to the edge and the floor is lava and it's going to be, you're all going to drown in lava.
Yeah, but the other one is going to have pseudo forces helping it.
No, there is no force. There's no force there. There is
the
no
rotating one,
actual
there
force
is.
helping. No, there's no force.
There is in the rotating frame. That's exactly what pseudo force is. It's a force that exists in that frame only.
There's no force though. There is no force.
There is. In the non-inertial frame, there is.
No, it just looks like a force. It's not an actual force. We know there's no force there. Zanuck said it 20 minutes ago. He said we know there's no forces there making it go left or right.
Yeah, they don't exist in the sense that they are not part of the inertial frame. They only exist.
It's just not real. There's nothing there. There's no force there. There's literally. He said it's mathematically derived force. There is no actual force there. This is for all things Zanuck said about 20 minutes ago.
Yeah. Okay. It's not a.
There's no
definition of force is not a force. It's a pseudo force then. So
there's no force. There's nothing that
there's
helps.
A pseudo force.
Nothing helps. There's nothing helping.
There's the pseudo force is helping it.
It's not helping. It's hindering you because it's making you take a longer path, which is going to make you drown in lava. The one you're going to take is the real. The one you're going to take is the real path where you make it to the edge and land safely on the edge.
No, the pseudo force in the rotating frame is what makes the drone take that curved path. So it's helping take that curved path.
It doesn't make the drone do anything. The drone goes in a straight line. You're just spinning underneath it.
Not in that frame. In that frame, it's spinning
underneath. You spinning underneath something doesn't make the thing do anything.
Yeah, but I'm not spinning in the rotating frame. I'm stationary in that frame.
If you're stationary, then yeah, you're going to take the straight line path.
No, I'm saying
if you were spinning though, if you were spinning, you could do the calculations and say, oh, I'm going to fly this path because this is the actual straight path and I'm going to make it to the edge safely. You could do it in both frames if you wanted to. You could land the plane safely on both, the drone safely in both frames.
Yeah, on the rotating frame, I would have to account for the pseudo forces of that frame.
Yeah, if you wanted to fly it in a straight line and get the 2 meters to the edge.
It wouldn't be a straight line, it would be a curved line. Then I'm using the pseudo forces to help me spend only the amount of energy.
It's a straight line. The drone only has enough electricity to fly in a straight line.
Yeah, that's if there's no forces helping it.
There is no force helping anything.
There are pseudo
You're just
forces
spinning
helping it.
underneath. That doesn't do anything to the plane.
It does. It makes
It does
it take a
nothing to
curved
the
path in that
plane.
frame.
You,
It does.
if there's a sky and I start spinning underneath it, do you think that does anything to the plane? It does nothing to the plane.
It creates huge pseudo forces in it.
No, it doesn't create anything in reality. Mathematically, it creates a pseudo force. In reality, there is no force. The jumbo jet does not know I got on a. I promise you, the jumbo jet does not know that I got on a merry-go-round and started spinning crazy underneath it.
All forces are mathematics.
No,
they're
some
just
forces are actual forces that have causes in reality. This is something that has no effect in reality at all.
It does. It's
It,
making the plane spin it would be impossible in that frame.
it's
That's
making
what
the
it's
plane
doing.
look like it's spinning impossible. It doesn't actually do that.
It does in that frame.
No, it doesn't do. It doesn't do anything in that frame. It only looks like it's spinning. We know that the plane can't actually do that.
I think we're in a loop here.
Yeah, like
What if you
this
did it
is
with your
fucking
eyes
dumb, dude.
closed?
It's so
Bacon?
dumb.
What if you did it with your eyes
This is,
closed? What's going to happen?
The position of the plane in my frame doesn't change depending on whether my eyes are open or closed. Nothing changes. My eyes are closed. The looks like is just a mere description of where it is in my frame. It has nothing to do with my eyes or what I'm actually seeing.
in reality, if you wanted to land the drone safely on the edge from the center to the edge, you would take the straight path because nobody wants to have the drone fall into lava. So you're going to do the real path because you only have enough to do a straight line path. You're going to make sure you do that straight line path to get to the edge because that's really how far the drone can fly is 2 meters.
Yeah.
Yeah.
Okay. Who's controlling the drone? The person in the merry-go-round or the person standing still?
Either one can do it. Like I said, all you'd have to do is account for the fact that you're spinning underneath it and you could get to the edge.
Yeah, if I'm on a rotating round and I just move it forward, it would take the curved path and you would only spend as much energy as it would normally because the curving of the path is not being done by the drone itself, it's done by the pseudo forces. So it would still get to the edge. Like there's no difference.
Yeah, and it would look curved to you, but it would actually go in a straight line.
But that goes back to what Zenik was saying. Like every time you say actually, it simply means like in the inertial frame.
No, I'm talking about
Then
actually,
sure.
like you actually only have one. You can actually only have enough electricity to fly for 2 meters. That's actual, right? Is that actual or is that some kind of reference frame dependent thing?
Let's go with it is actual.
Yeah, I thought that's what I thought. It is that you actually only have enough electricity to fly for 2 meters. Okay.
Yeah, but if
So if you want to
something
fly
pushes it, then it might go further, right?
well, nothing's good. There's nothing's gonna push it. There's no wind. We're in a room.
Yeah, but if it was, it would increase, right?
Well, if your mom never met your dad, we wouldn't be having this convo, would we?
Okay, but if something pushed the drone, it would
What if a
go further,
unicorn
right?
popped out the wall when we were doing
Oh,
this? And the
if you answer mine,
Kool-Aid
I'll answer
man.
yours.
What if the Kool-Aid man busted through the wall while we were doing this?
I don't know what that is. Can you answer mine, then I'll answer yours. If I push the drone, it would go further.
Yeah, if I knock the drone out of the air and it's not flying anymore, it's just on the ground. Yes, we could fuck with the drone we could fuck with the drone if we wanted to. Yes.
Okay, so the statement that it can only go for 2 meters depend on nothing helping it, right?
Yeah, nothing else in this scenario. Nothing else is happening. There's no wind. Nobody's going to swat it out of the air. No one's going to push it. Kool-Aid man is not going to pop through the wall. There's no unicorns or leprechauns. It's just me and you in a room with no wind. No, there's no other.
Yeah,
nothing's going to happen.
If nothing's happened helping the drone, then yeah, it can only go 2 meters.
It can only fly 2 meters. Yes. So you're going to take the path. You're going to take the actual path, the actual 2 meters that the drone can fly. You're going to do that and go in an actual straight line to get to the edge. Because if you curve at all, you're not going to make it to the edge.
Sure.
Yeah. So you're going to do the real path, the straight one, not the one that looks like it's straight.
Because you said there's nothing helping, so there's no.
If you do the one that looks like, it's going to get to the edge, and it's not going to make it to the edge.
Yeah,
nothing's helping it. The pseudo force you think is there there's no force there. It doesn't help do anything.
Exactly. As soon as you say there's nothing helping it, then I know there is no rotating frame here, right? We're only in
Yes.
the inertial frame. So of course
Okay.
you're just taking
Okay. Hold
the
on.
straight path.
Let's reset. The thing's not spinning. You want to fly it to the edge. You're going to take a straight line path to the edge. Now I start
Yeah.
spinning it. Do you think that changes something? And you're not all of a sudden not going to do a straight path to the edge? Of course, you're still going to do a straight path to the edge. Spinning it doesn't help you do anything.
No,
It's only a
spinning the
looks like.
merry-go-round is introducing a frame where the drone is being helped by pseudo forces.
No,
So the initial statement,
doesn't, dude. If you get on a merry-go-round under a jumbo jet, you're helping the jumbo jet out, or do you not affect the jumbo jet at all?
you do in that frame.
Yes, and in that frame, you're still going to fly in a straight line path, the actual real straight line path that the drone only has enough electricity for to get to the edge.
Yes, because in
It's
that
not. It
frame there
doesn't
is no
do
pseudo
anything.
forces.
It doesn't do
Yes,
any. You spinning
it-
doesn't do anything. It just makes it look like it's deviating.
yeah, it doesn't do anything for the inertial frame, but it does for the non-inertial frame.
Nope, the plane still takes the path it's going to take regardless. You don't affect the plane at all. Zero. All right, I got to
You do
go
in
mow
that
my lawn.
frame.
Have fun. Have fun with not knowing what's going on in reality and what things that look like you think is real. It's
Feeling
fun.
is mutual, Jerry.
It's fun. Must be fun.
Sometimes.
You must be Turkish bacon
Why Turkish?
because Turkish like to spin, and when they spin, they see things that aren't true.
Didn't get the reference.
Turkish like to spin. I don't get it either.
I wonder what Turkish bacon tastes like.
Does Turkey have bacon? You mean from the country turkey or from the animal turkey?
No, the country turkey. Is their bacon
Okay.
different? Like Canadian bacon, you got Turkish bacon. I wonder what that is.
I think they're mostly Muslim, so you're probably not gonna find much bacon there.
No,
You know
it's
the special
no
dance.
such thing.
The Turkish, they do a special dance where they spin nonstop.
Ah, that's the joke then. Sorry, I missed it. Took you too long.
So you are Turkish bacon.
I'm not Turkish. You know me
Yeah, but you
for
see spin.
years. You should know where I'm from at this point.
From my reference frame, you are Turkish bacon.
I don't think a reference frame changes country borders.
Yeah, but is it a pseudo reference frame I'm talking about, or a real one?
Well, if it has country borders and it's rotating with the Earth, it's not inertial then. It would be a non-inertial frame. Yo, is Zenix still here?
I'd like to get the information on how what was the other guy's name? The German guy. He said he can measure the pull from the moon on the Earth. What device is that?
A gravimeter.
Oh, he didn't say he could. He said it could be measured with a gravimeter, right? Not sure he has one.
Yeah. I don't have this kind of fine or high accuracy gravimeter.
So you've never tested it for yourself?
Correct, because I'm not a scientist who works with gravimetry. But PhD Tony is, and he did.
Haven't seen him for a while.
Yo, PhD Tony has a gravimeter?
PhD Tony was working for, I'm not sure if it's a oil or gas company, measuring gravimetrical changes and finding resources, subterranean resources.
Nice.
So I think he's actually a mathematician, if I'm not mistaken, but he was working in this gravimetry measurement field.
Yeah, we had a plane at our airport a couple of months back, and he was flying surveys, and they just fly back and forth like in a grid, and he's doing gravimetric evaluation of the county, the ground underneath, and they're looking for titanium.
So you need to know what gravity is made of to be able to measure it, right?
Really?
Sure.
Do you?
I need to know like what stuff are made of to weigh them or to measure their velocity. Like if I use a radar gun, I have to know what the thing is made of.
Yeah, like what frequency, for example? Like how would you describe like the
Frequency.
gravity itself? Like what essence is it?
What essence?
So,
I mean,
for example,
just
without
That
knowing or understanding what sound is, I still can hear you, right?
means what
Okay,
does
so
it
like
smell like?
sound comes that you can measure it with a device that can measure frequencies. Like how do you actually measure gravity? What is it? What's the essence? What's the composition, the molecule? What is it?
You don't need to know that. You can measure the effect of gravity, and you cannot measure sound itself. You can only measure the effect of sound on a membrane that is moving forward and backward and creates electricity. And by seeing that electricity, you can then calculate backwards what kind of sound pressure you had before moving that membrane. So you don't need to know that air molecules are pressed against each other and are moving forward backward to know what sound is or to measure sound. When Bell invented the microphone and the loudspeaker and this basically the telephone, he did not know necessarily how it worked on a subatomic level, but he knew the effects.
And there's a distinction between gravity and gravitation. Gravitation is very, very physical around us, easy to measure, absolutely thoroughly understood in its behavior. But gravity, you're right. That's like a leading edge study in frontier physics research. But gravitation, no. You measure gravitation all the time. You just don't even know it.
okay. So gravitation, you mean like the effects of gravity?
Correct. Yeah,
Yeah,
gravitation is a
gravitational
net
forces.
effect. Yeah, gravitation is a net effect.
Right. Got it. So what do you think? You think it's quantum, or you think the relativity is going to prevail?
That's at the leading edge of research in physics. I mean, I'm not going to take an opinion on what I think it must be at the fundamental level because they're not sure themselves. That'd be folly. But the gravitation, acceleration of gravitation, the inverse square law of gravitation, the coefficient or the proportionality of gravitation to mass. Yeah, that's mechanical. That's easy to measure. Orbital
Gentlemen, I'm
mechanics.
sorry to interrupt, but I do have one announcement to make. Starting a little bit late, but the next trivia that I'm going to be doing will be happening at 3:30.
What's up, NASA Shill?
Not much. Just doing chores around the house. Sat down for a little bit before I ate dinner. What's up?
All right. You want to maybe have a full-on battle? I'm just kidding. Have you ever
Just
have you ever told anyone your real name in this thing, or you just always NASA Shill?
I never talk
I mean,
about
you
it.
came in like, "What's up? What's up?" Like you want, "What's up?" You know what I'm saying?
I just plunked, drinking some water. We're doing a bunch of tree work and hedges and
You got
all that fun,
extra fluoride.
all that fun stuff.
You drink water with extra fluoride in it, don't you?
I do, and uranium too. So I glow in the dark.
Fluoride added.
That might be safer than fluoride, actually.
Actually, not.
Wasn't that the stuff the dude was running around drinking? Or
I have
was
a
he just eating uranium? Who's
we're in
that
a
guy's name?
we're in a well, so I don't think it's fortified.
So what do? You like order fluoride offline and then sprinkle it in, or how do you get your extra fluoride?
Well, I I call into the local Illuminati club, and they give it to me.
You go straight to your nearest aluminum processing plant
The
and just get it
Illuminati.
straight from the source.
I don't know where does fluoride come from. I have no idea.
It's a toxic waste, hazardous waste product from the aluminum industry.
Anything's toxic if you take it in
You get
enough
like a nickel a
quantity.
can though.
Aluminum. They're the Illuminati. Illuminati.
That's what I thought. I thought he
I knew where you
misunderstood
were going right
Illuminati.
away. That's brilliant.
I,
Aluminati.
aluminum naughty.
Aluminium.
Aluminium. Yeah.
Aluminium naughty.
Yeah, the Illuminati.
Illuminati or something.
You are relentless, though, dude. You are not giving up on this flat Earth, bro. Like you are
Absolutely relentless till he's
just
dying on
not
this hill.
giving up, dude. There's not. It doesn't sleep for a day. This flat Earth for you. It is just.
Oh, the fact that it's 2026 now and people still think the Earth is flat, I find that pretty freaking funny.
And people like you still love asking for evidence for it. So what's up with that?
You got any?
Oh yeah, I got the
Yeah.
goods.
Like what?
How much money you got?
Oh, it's what it costs.
Bro, we give it to you all the time. Like
No,
every
you
day
don't.
we do this. You got any flat earth evidence? We give you evidence.
And you
And
never have
I don't
any.
know what that's nuh-uh, Gio. Gio, that's an actual nuh-uh, right?
No, you never have any. You
Gio,
you
is
never
this a
have any.
nuh-uh what Peyton's doing
You
right
never
now? Is
have.
this
You never have any positive evidence for the flat Earth. You have what you think is evidence, but most of it is anti-globe evidence. You guys aren't flat earthers; you're just anti-globers.
oh, that's still not true.
Well, what's your evidence then?
Bro, how many times have we done this dance?
You haven't done it
You
because
gonna
you
do it
haven't got any
again?
evidence. Well, you got any evidence?
I'm home with my family and shit. We're about to have a birthday party over here.
Oh,
Every measurement of level
incorrect.
has measured
Level,
horizontal. I didn't even finish this. Didn't even finish the thing.
incorrect. Level and horizontal
I
are
did not
different
even
things.
finish the thing, and he couldn't help it.
No, it's incorrect because
Does
level.
that
I know
sound
where
like
you're
a whole
going.
sentence? Every measurement of level?
Yep, every measurement of
That
level. That's incorrect.
that is not a complete sentence.
Well, okay, but every measurement of level shows level, not horizontal.
No,
And
every measurement of level is measured horizontal.
incorrect.
It only starts. Hold on, bro. I know you think it's incorrect. That's why you don't
No, it
think
is.
this is the evidence, but this is
I don't
evidence
think
of a
it's
flat
incorrect.
Earth.
I know it's incorrect because it doesn't measure horizontal; it measures level.
Every
The two.
measurement of level is measured horizontal. You don't have any measurements of level that show that level curves. Zero.
Incorrect.
You have zero. Then
Incorrect.
bring one.
Because you can determine horizontal with a theodolite
Bring
and
your
level
measurement
curved
of
away from it.
level curving. Give me the measurement of level
Well, you
curving.
determine level, and then you determine horizontal by the theodolite, and the two disagree with one another.
No, the theodolite is not a measurement because you've never measured which way the light's bending. You just have a guess of which way the light's bending. It's
And
actually an
we know which
affirming
way
the
the light's bending.
consequent.
No, it's
It's
not.
actually an
Stop what you're
affirming the
saying.
consequent. You don't actually know which way the light's bending.
Yeah, we actually do know which way the light bends.
You're just saying you do. You've never actually measured it though. That's what I'm saying. You have a measurement. You say
We've
you know which
measured.
way the light's bending. You've never measured which way the light's
We've
bending.
measured which
We've
way the
done
light.
this dance like 8,000
Yeah, but the light
times.
doesn't. The light in a theodolite measurement of a couple miles, light bending is
What?
is like a small error bar.
Whatever. You're just saying it's a small error. You don't know which way the light's bending because you've never measured which way it's bending. You have
How do you
nothing.
measure? How do you measure which way the light bends, Jeremy?
Definitely not with anything that has to do with refraction. You're going to have to use some other tool other than a
Oh,
refraction,
guess
which
what?
is what we
Guess what?
have. We have the measurement, the actual
No,
measurement
you
where
don't.
there is no refraction in it and there is no
There is
guesswork.
no
We
refraction.
just,
Wow. Is
yes,
there
when
an
you have a
atmosphere?
spirit level, when you have a spirit level against the wall,
Spirit. That's
and
level.
this,
That's not horizontal. And
the
how far are you
spirit
measuring with the
level,
spirit level? How far are you measuring with the spirit level?
when you have the spirit level against the wall, there's no refraction. Yes. It's touching
How
the
far are you
wall.
measuring with the spirit level?
I don't know. You go 8 feet, maybe 12 feet.
8 feet. That's a really big spirit level. 12 feet. That's a huge spirit level. I've never seen a 12-foot long spirit level. That's only
I
one of
don't
the
think I
biggest
have
one.
either.
Yeah, I think the biggest one I've seen is like 4 feet.
I have a 6-footer in the shed, so I mean, you're not that much of a handyman, probably.
4 feet is huge for what I do. I do a lot of. I have a torpedo level.
4 centimeters is huge for what you do.
Not bad, but okay.
I can't
So how
get to the
much?
soundboard fast enough. Hold on.
Yeah, boom ching.
Yeah, I got it.
Nice work. Golf clap.
How much curvature would you expect on the globe over 8 feet?
It doesn't matter. The whole point is that
No,
every
it doesn't
measurement of
matter.
level, every measurement of, you wouldn't expect much. It'd probably be
Exactly.
immeasurable. However,
Yeah, exactly.
every measurement of level measures horizontal. You have no
Correct.
measurement of level curving.
That's incorrect. Again, we do. You just refuse it
Where?
because you say, "Well,
Bring
you
it.
don't know which way
Bring it.
light bends." Okay, I told
Bring
you,
it.
and you said you don't know which way light bends. You just totally dismissed the fact. In the meantime, you measure over 8 feet. And hold on a second, I'm going to figure this out for you because, you know, okay, hold on. Google. Okay, over 8 feet. You want Sajda or drop? Let's go with Sajda. You know, that's the hump, and that's hump to you guys. Over 8 feet. Over 8 feet, the drop is 0.4 microns, 0.5 microns. And the Sajda is 0.1 micron. So it's pretty damn small. I would say they're the same measurement, unless you're measuring extremely precisely. I think a bubble level is not that precise.
I think the best small scale measurement is the Taylor toe tank, where the top rail has to be concentric with the body of still water in the channel. And it's called out and measured very particularly by the Bureau of Standards. You know, it's the science you want. But said, oh, it's never been measured. Yes, it has. Even in short 2,000-foot stretches, like at the Marine Engineering Tow Tank, which is not just a one-off. Many countries have their own marine engineering tow tanks. I posted it.
Who's that, Larry GPS? You thought there was a measurement of spherical triangles, and who was wrong on that one, my man?
There are measurements of spherical triangles. What do you mean?
Oh, yeah. Yeah,
Shoe
he
Bill, where
doesn't
they
like.
at?
It's
Shoe Bill,
right
do you
in
have the
there.
measurements?
It doesn't have the pen and ink photocopies from 1895. Correct. It does have the abstract, the product of everything they did, the abstract, and the net result. Yeah.
Here you go, Jeremy.
If
Here you
that's
go,
not good
Jeremy.
enough, if that's not good enough, then you're going to have to question every white paper that didn't photograph their lab notes, but transcribe them into white paper.
I
Because
mean, you just don't have a measurement. It's all
well,
Right
good. You
here,
just
then
don't
Jeremy.
have it.
well, it's not
Right
good
here,
enough
Jeremy.
for
I
you.
just posted one,
It's
Jeremy.
not good
Jeremy,
if it's
Well, it's
not.
not that
If
it's not good enough. You just don't have it. You don't have one for me to be not good enough or good enough. You don't have a
well,
single measurement.
there you go. No problem.
Jeremy, I just
There you
posted
go.
one.
I know.
You could do this yourself. Why can't you do this yourself? Go get a. I'm sure you're at the birthday party. Your kid's got a ball. Go borrow it and draw a triangle on it. 3 90-degree triangles. Spherical axis demonstrated. You could do this. You know, if you had all the notes, that still wouldn't be good enough because they probably miswrote them.
If you had the notes, you'd have a measurement, and you don't, and you don't. So
Well, no, you'd have some other problem with it. Can you do this experiment yourself? I
I may
mean,
have another problem with it. I may not. Either way, you don't
yeah, you
have it.
always do. No, you
You
always
don't
do,
have it.
Jeremy. Hey,
Straight
look
up,
at
you
this,
don't have
Jeremy.
it.
Did you see the one? Do you see the little video I posted? A little GIF.
You have no
GIF.
measurements of anything.
You see a little GIF I posted, Jeremy? You could do this. Show yourself that triangles have more than
Don't
180
worry about what
degrees.
I can do. You
Why
can't
not
do,
do
and
it?
you have no spherical triangles
Why
that
can't you
show
do
that
this,
Earth is
Jeremy?
curving.
Jeremy,
You
why
have
can't
no
you do this?
spherical triangles that show that
We
Earth is
do.
curving.
We do.
There's not a single measurement of a spherical triangle big enough to show Earth
Incorrect.
is curving.
Incorrect.
Larry don't have them.
Well,
Shoe Bill don't have them.
why can't you do the little experiment I showed you right there?
You could do it on a ball. I don't doubt that there's a spherical triangle on a ball. However, to show that Earth's curving, you have nothing, my man. You have
We
no
do.
measurements of anything showing anything about Earth curving.
What do you mean? The big surveying things they did across Europe, across Asia, across the United States.
Okay, find one of the measurements.
What do you mean? You want me to go back in time and videotape them taking the actual measurement?
You said you have a measurement. Just bring the measurement, bro. I don't
I
even
want
know.
to. I
There's
want to
nothing
know.
to really
I
talk
want.
about. Just bring the measurement, and
What do you
then you'll
mean? There's
have a
nothing to talk
measurement.
about. What do you mean? There's nothing to talk about. You're just saying no to the whole concept of surveying. Apparently,
I'm not saying no. You don't have anything for me to say no to. I'm asking
define
for a
what it meant.
measurement.
Define what you want,
I'm
Jeremy.
asking for a measurement. You don't have one.
Define measurement. Define the measurement you want. Tell me the information that'll be good enough for you. And crickets.
I mean, Jeremy, even if they had a spherical triangle that they claim, wouldn't you also then contest that they still don't know which way the light's bending and refraction?
Oh, I would most certainly have issues with it, but there's nothing to even go. There's nothing to even go off of though in the first place. You know what I'm saying? Like the measurement's not there for me to even address. Like they don't have a
Tell me the
measurement.
information that would be good enough for you, Jeremy.
A measurement.
What do you mean by that? Tell me the
You don't. If you
exact
don't know
thing.
what a measurement is,
No,
there's
you need to
no
tell me exactly what you want so I can go get the right information for you, not waste my time.
one single spherical triangle measurement.
What do you mean by that? We have that information.
You
I've
don't
been
let her
given that
then show
information.
it. Bring it, dude. It's not in the 900 page arc of the parallel document. I promise you that because Shoebill doesn't even have that. You're not going to be getting out of that thing.
Bill, do you know what he wants? Can you translate it? Is he here still?
Yes, because in the 1900 report, where they have the abstract of angles, which are just the result of a week-long observation at a specific point and the angles measured, which are typeset, and they're not pen and ink field notes. So once you transcribe it into text and print it in a document, it's no longer measurement because it's not the handwritten pen and ink on parchment done in 1895 on a mountaintop.
No, I'm sorry. That's not it. It's they have it all averaged out with weighted means and everything, and they don't have just a single spherical triangle measurement in that whole paper. It's not that I don't like that they printed it out or it's on a computer. That's fucking ridiculous. The information's not there.
Only to the blind man.
Well, I mean, the thing is, if there was a documented like aspherical triangle, I mean, it is true that those are all like weighted means and so on. But if there was one, technically, we could go out there and try to duplicate it.
Yes, you can go out there and duplicate it, and yes, that'd be difficult. It'd be a significant project, but that is possible. Knock yourself out. And what they have is the raw field notes and the adjustment post field surveys for publishing, but they have both. They have input and output.
They got everything but one spherical triangle showing that Earth's curving.
You could say that all you want, but that does not comport with the reality of the document when read in detail.
Inside the document, in detail, there is not a single spherical triangle measurement. There's a bunch of weighted mean averages. There's no
No,
actual measurement of
the
one
weighted.
triangle.
Well, again, that's just, you have an opinion that no other academic institution has.
That's not an opinion. You even agreed with that because you went to find them in the Hall of Congress or Library of whatever, and you
Yeah, and
couldn't even find them.
I went looking for the pen and ink on paper because I
No, you
thought
went
that's what
looking for the measure. You went looking for the actual measurements because me and you were like, "Oh, those are averages." You're like, "Okay, I'll go get the actual measurements," and you couldn't fucking find them.
you're right. In
I know.
the inquiry I got from the Library of Congress could not find the pen and ink on paper.
The measurement. You couldn't find the measurement.